Pericyclases is a name that we invented to describe a new class of enzymes that catalyze pericyclic reactions. Enzymes are nature's catalyst to make it possible for life to exist. Pericyclic reactions are a very common reaction in chemistry, things like the Diels-Alder reaction and the Cope rearrangement. They're a class of reactions that were defined by Woodward and Hoffman back in the 60s, and they're reactions in which all of the bonding changes occur at one time on a closed curve or a cycle.
These reactions have been discovered over the last 100 years, and they have been widely used in chemical synthesis. Chemists from all fields have used them to synthesize a whole range of small molecules such as pharmaceuticals and commodity chemicals. They were thought to be abiological or invented by chemists. But now we know that's not to be true. Our team has discovered this family of natural enzymes called the pericyclases, which catalyze pericyclic reactions in cells and have done so in millions of years, presumably. Before this discovery, we only knew a few enzymes that could catalyze specific types of pericyclic reactions. But now we have opened up a whole new toolbox. We can catalyze new reactions with exciting new opportunities for chemical synthesis.
Collaboration is really essential for discoveries like this. We work with people all over the world, exchanging scientific information among people who have very different scientific abilities. For example, Professor Zhou in China is an expert on X-ray crystal structure determination. And Yi and his team, Cooper and Masa, who are here, can isolate enzymes and determine their function. And Professor Neil Garg in our department can synthesize molecules that we need to test how enzymes work. My group, as well as Marc Garcia Borges in Spain and Feng Liu in Nanjing, China, are able to do computer calculations that simulate how these enzymes work in order to understand how they work and to make them work better. It's the combination of these skills that allow these discoveries to be made.
Collaboration is absolutely essential for such interdisciplinary research. Professor Hauck and I have been collaborating over the last decade on different types of enzymes, including the pericyclases. In addition, colleagues in China and Japan have played pivotal roles in our work, such as Professor Jiahai Zhou in China and Professor Kenji Watanabe in Japan. This is truly an international effort of scientists from 3 different continents, and only such collaboration has allowed us to make the quantum leap in understanding nature and applying to better chemistry.
Well, our team has a huge range of different skills, ranging from genetics and biochemistry to structural biology and the computational sciences. And we've combined all of our skills to learn how enzymes have evolved and the mechanisms behind the catalysis.
It is so exciting to learn how nature works. Now we can modify the enzyme and control which reactions they catalyze.
By using enzymes from nature, we're steering away from the use of toxic chemicals in dangerous reactions and making synthesis greener.
And having a wonderful time learning new things.
Pericyclases.